want to solve number 39 and 3.4. And what was your idea?
Get rid of the bottom numbers.
Yeah, I'm bad at fractions. How do I get rid of the bottoms?
Multiply the top by 10, like both sides, and the bottom by 6.
Okay, so we'll look at this first fraction and see that the common bottom is 10, right? And then blast everything but that. Okay, so we're going to take this guy, we're going to multiply by 10. We're going to take this guy, we're going to multiply by 6. You guys see that? Okay, so, whoa, I should probably organize my thoughts a little better. Let me do this. Say this guy, multiply by 10. This guy, multiply by 6. Probably not that much better in terms of organization. What do I get when I multiply this thing by 10?
20.
Go ahead, Jamie. 5x? Two y is 8. If you want to write that down and go through and cancel, that's awesome. Really do the extra steps. So if I was to write down all those extra steps, that'd be, all right, I'm going to take 6 and multiply it by this whole thing. So I've got 6 times x over 6 minus 6 times y over 2 is 6 times 5 over 6, right? And then I'm going to go through and cancel. So that stuff's a onesie. That stuff's a onesie. And this stuff is a 3z, right? 6 is 2 times 3, so I can cancel one of the 2's. So I'll be left with a 3 on top. So all told there, I've got my first equation, and this one becomes x
Minus 3y.
minus 3y is 5. Okay, so now I might just do this whole problem as though I had started with this. So I've got 5x plus 2y is 8, and x minus 3y is 5. Okay, now they told me that I had to use substitution.
Well, you have the x, so that's pretty easy. You just add the 3y.
Okay, so let's take this second guy, right, and do add 3y to both sides. So I'll get x is 5
Plus 3y.
plus 3y, and then what do I do with that information?
You can plug it into the first equation.
Awesome. I take this stuff and I put it in there for x, right? Okay, so I get
25.
5 times
5 plus 3y.
5 plus 3y
Plus 2y equals 2.
plus 2y is 8.
And you
And
can
then
multiply it out.
distribute. So I got 25 plus
15y.
15y plus 2y is 8.
And you can just combine the ones too.
Okay, so now I should look for like terms, right? So there's a 17y and a
25.
is, whoa, what did I do?
Oh,
Subtracted 25.
Yeah, let's combine all the like terms, right? There's y's and numbers. Let's get the numbers together. Y is my preferred place to get the numbers together on the other side.
Yeah, because you're trying to go up.
Yeah, because I'm trying to find y, right?
So you get negative 17.
So I got negative 17, so then I apply
Divide by 17.
this step, by the way, was minus 25. So this is then divide by
17.
17.
So you get y equals negative 1. Negative.
Cool. Am I done? Do I circle that? Move on with my life?
Nah, you just
Oh yeah, it's got to go back in for the y in the blue stuff, right? Why did I pick the blue stuff to put it back in? Yeah, because that's easier. I could put it in anywhere, really, right? At least as long as I do it before the blue, right? Because after the substitution stuff, there weren't any x's, right? So putting -1 in there is only going to check that -1 worked. Okay, so I put it in the blue, and I find out that x is
2.
2. Awesome. Cool.
And that's the point where this one was.
Yeah, so if I was thinking about this graphically, I'd look at this thing, and with a little rearranging at least, these are y equals mx plus b's, right? So if I rearranged those and wrote down the slopes and intercepts, I could draw a good picture. This is not a good picture, but it's a picture, right? So maybe I have two lines that look like this, and what I found here is what?
Cross at -1 and 2.
Oh yeah, so this
2
picture
and
is
-1.
clearly not right, because I know where they cross. They cross at
2 and -1.
2 over 1 down, so they cross over there. See that? So whatever they look like, it's not this. It might be something like this, of course. Oops.
Not like that.
I moved the dot. So this is 2. This is -1. You guys see that? A little rearranging would get us there. Cool. You guys want to do that rearranging and read the slopes off? We can.
Sure.
Okay, let's figure it out. So I got this and this. What form am I trying to reach?
Y equals mx plus b form.
Okay, so I'm trying to get the y by itself, right?
Yeah.
Okay, so that's just straight up solve for y. So with the first line, I've got x over 2 plus y over 5 is 4/5, right?
So subtract x over
2.
Okay, so we subtract x over 2, so I've got y over 5 is 4 over 5 minus x over 2. I was subtract x over 2. Then what?
because
You have to get rid of the 5.
Yeah, get rid of the 5 on the bottom. How do I do that?
You just multiply by 5.
Okay, multiply by 5. Okay, so if I multiply by 5, I'll get y is
4 minus
4 minus,
x over 10.
no,
Wait, no. 5.
5x over 2, right?
Yeah.
Because when you're multiplying.
Yeah,
Because I'm multiplying the fraction 5 over 1 times this whole thing and distributing. Okay,
And then
so to read this line off, maybe I convert it to, right, maybe I swap the order
Yeah.
here.
So
Or maybe I don't.
so
What's m here and what's b?
Your
negative m would be
negative 5x over 2, and your b is positive 4.
Well,
What?
What's the difference between what I wrote and what you said, Jacob?
Negative 5 over 2, and I said the b was positive 4.
Yeah, you threw an x in the m.
Oh, yeah, sorry.
Right, m doesn't have an x in it, m's a number.
I missed
It's the coefficient on the x.
X, yeah, okay.
Don't worry, it's just I'm used to hearing that
I
one.
was like, whoa.
Well, like, no.
Cool. All right, so that's the first one. So if I wanted to draw a good picture of this line, I'm leaving the intersection on there because I know where that is, right? And this line goes through, b is plus 4.
So you'd start at positive 4.
So I'd start at positive 4, and I know it goes through the intersection point, right? If I wanted to be totally sure, I could check, okay, it goes
Down 5 over 2.
down 5 for over 2. So down 5 over 2 is indeed that point of intersection. So that's making me feel pretty good about my solving. At the very least, this first line goes through that point. So now the second line, I've got this guy. So that's x over 6 minus y over 2 is 5 over 6. Wow, that got really messy.
Subtract.
We can subtract x over 6.
So I should subtract x over 6. So I've got minus y over 2 is 5 over x minus x over 6. Then what?
Multiply by -2.
Yeah, multiply everything by -2.
Yeah.
I would advise doing that in 2 steps
Yeah.
personally. 1, flip the signs on everything. 2, multiply by 2. But it's all you get. So I flip the signs, then multiply by 2.
So you get y equals negative
So I get y is negative,
10. Negative, I don't know. Fuck, I hate
sure,
that.
10 6
Yeah.
You good?
plus 2x over 6.
And then you can just reduce it out.
And then I can reduce a little bit. So I find out that m is something and b is something.
M is 2 over
One.
6.
1/3.
1/3, yeah.
Okay, m is 1/3, 2 over 6, right?
Okay.
It doesn't really matter, it's a slope, right? So they're the same. And b is
Negative 5/3.
-5/3. Okay, so I could throw this on my picture, right? It goes through the y-axis at, what's -5/3? Ballpark that.
Like 1.
Okay, 1 and
2.
2/3, but negative, right? So I go down 1 and then a little bit almost to 2. So like here's my -5/3. And then the slope says it goes
Up 1 over 3.
up 1 for over 3.
Yeah, that looks about right.
You see that? So if I go up 1, I'll come up to -2/3 and I'd go over 3.
Yeah, so it goes.
If you can see the shadow of the...
Yeah.
One of my lines was really good before. Cool? So we do indeed get a at least plausible point of intersection there. It would be much harder, right, to graph these and then eyeball that point of intersection, right? It's much easier to get that algebraically, especially because it doesn't have to be at integer coordinates, right? That intersection could certainly be a nasty fraction, comma, horrible fraction.